So in this video we are going to look at how we can access the common parameters of SPRS control module. These parameters are the configuration parameters. These parameters are common for the whole rack. The rack consists of one control module and 4 power modules. So parameters which are like for configuration purpose, you want to set the 4 modules in which mode: 1P1, 1P2, 2P1, 3P1, vice versa. So that configuration we can do through Profinet communication, as well as we can set the current limit, we can set the voltage alarm limits. So all the configuration point of view, the things that has to be done into the control module, those we can do it from Profinet communication. How to do that we are going to see in this video now. So we can see the data packets that have been mentioned in SPRS communication manual. To download this communication manual, we can go to Autonics website, and at the most bottom side in the downloads section we can see SPRS series communication manual. This is what I am referring right now. So in this manual, if we can see, these are the packets, of which the first byte is system bits. Then we have after 4th byte 2 bytes are not used, which are 5th and 6th byte, and then 7th byte is having 2 bit addresses at location 6th bit and 7th bit, which are for error in reading values, error in writing values. So these are the errors that may arise during read and write operation of the configuration parameters in SPRS control module. Similarly, if you want to read any data, the data will come in address over here in this byte. So the data will be of 16-bit. Okay, the way we have a 16-bit, that is a word registers in Modbus, like that way the data will come and appear over here, that we have to check. Okay, then how to give the read command, how to give the write command, how to mention which address we want to read or which address we want to write. So that those packets are available in the output sections. So these all are the inputs. If we move down a bit, so here we are having the output sections. In this output section, the first byte which is present has a read request bit, write request bit at 6th and 7th location. Okay, as well as where to mention the read address. The read address will be mentioned in this output byte. Okay, and the write address will be mentioned in this output byte. So first of all, we need to check which address we want to read, which address we want to write. Now where this address will be present? So this address is nothing but the same mapping table of Modbus. Okay, so same Modbus mapping table can be used, and we can get the data mentioned in the Modbus mapping table. Okay, once you enter the address for reading or writing, we can activate the read and write command over here. We can check if there are no errors present, and the data then will be available in the read address. Okay, or if you have written a data, the address will go to the respective mapping address of your SPRS unit. Okay, the data you want to write, that write data you can put it over here in this byte. So we are going to check how this mapping works in Profinet and how this data can be sent and received. So now let's see how the mapping is possible in Profinet communication. We have already configured a project, and we have also added the GSDML file configured the GSTML file in the device configuration, and it has also generated its respective process image input and output addresses as per the free addresses available. So these are the process input output mapping that has been applied to the SPRS device. Okay, so same, if I try to compare it side by side, okay, so we can see this is nothing but the first byte here. 2 bytes are not used, that means byte 2 and byte 3 is not used. Then we have byte number 4, so this will act as byte 4, and this will act as, you can see this is an integer location, so it will take 2 bytes, byte 5 and byte 6. Okay, so this is how this 6 bytes have been mapped. Let's see the same in the SPRS tags. We can see this is the first byte 0 to 7, then 2 bytes are not used, so these 1, 2 and 3 are not used. Then the 4th byte for error information, and 5th and 6th byte, so this is a word location where you can mention where you will get the read data from the device. Okay, now similarly we can also compare the output addresses. So let us now see the output addressing that will be used to read the common configuration data. So we can see here in the SPRS process input package or the packet, the output address is having 8 bytes. The same thing when we refer it with the communication manual PDF, the mapping has been shown in such a way as shown here, where these are this is one of the byte, and these are 3 different word addresses, each having 2 bytes. Okay, so these bytes, when you actually map, this 8 byte is actually the last byte. So we are having over here 7, 1 to 7. So this write data is actually present in word 7, that includes byte 7, 8. Okay, write address is present at bytes 5, 6, that means word 5, and the read address is present in word 3, that includes byte 3 and 4. Okay, and this write HS is present in byte number 2, that means byte number 1 is not used. Okay, so this is the address mapping for the bytes 1 to 8. Okay, I will not be discussing anything about the control outputs. A separate video is there, you can check out how this control output bytes work. Okay, so let us see how the tag tables have been formed in order to accompany this mapping. If we open up the SPRS tag table, we can see here this is byte 2, so byte 1 has not been used here, and then this is the byte 3, this is word 3 includes byte 3, 4, word 5 includes byte 5, 6, and the word 7 which includes byte 7, 8. This is how the mapping is. Okay, where these are, we mentioned the addresses to read, addresses to write data you need to put over here, that will be written into the configuration, and these are the commands: read command and write command, read request and write request. So that is how the mapping is there. Now I am already connected with S7-1200 PLC, which is right now in communication with the SPRS unit. You can see in the video besides. Okay, so if I just tilt the SPRS, we can see here the communication is happening between PLC and SPRS through this Ethernet cable. Okay, if I remove the Ethernet cable, we can see bus fault comes in SPRS as well as on the PLC. Okay, if I connect the Ethernet cable, the bus fault goes away. Okay, so these are communicating with each other, and we will access S7-1200 and we will check how to read configuration and write configuration into SPRS control unit. Now let us perform one demonstration or an exercise to read one of the configuration parameter from the SPRS control module, as well as write one configuration parameter to SPRS control module. There is already one example which has been provided in the communication manual. So this is the address 41441. Okay, so it's an holding register at an offset of 1441. This holding register gives us the wiring method which has been set in the control module 1P1, 1P2, or which of the method as per our power modules connected and the load requirement. So note this address which has been mentioned over here. It's not something a new mapping table, it's the same Modbus mapping table present in this same manual. So no need to refer anything else. The same Modbus mapping addresses are valid over here through Profinet communication. Okay, so let us check at 41441 what data we get. Okay, whether we are able to fetch the correct wiring method from the SPRS device or not. So going to our TI portal, I am already online and I have already taken the registers that I require the most. That if there is an error, these are the read write errors: read data, read address, write address, and the read write request. But one problem over here is I cannot directly write the address, or I cannot directly read the data, because this data is having an say big endian type of format through which the data is sent and received. Hence the data is not directly visible to us. We need to swap those bytes and check the data. Okay, so for that I have taken few of the global memory registers over here, okay, in MW series. So for the read Modbus address, whatever address we provide, we are swapping the bytes and then sending the data to the read Modbus address. Similarly, read Modbus data, whatever is received, that data is also swapped, and then we see the data over here. So all these addresses I have swapped it. What addresses will be required to be swapped? The all W addresses. So read data, write data, read address, and write address. These four. Okay, and this is one of the trigger that through which I will be sending the data to. Okay. So let us. So if we check here, see, I'm just taking the Modbus addresses using the swap instruction and sending the data, or vice versa. Whatever data I received from IW5, I am swapping the bytes and I am reading it into the temporary memory. Okay, so for reading I don't require a trigger. Okay, but say to change it I will use the trigger. Okay, now I'll be using the read address 41441 as we discussed, as we checked from the manual, 41441. Okay, and I will be modifying this read address. Once the read address is modified, now we will activate the read request. Read request activated. We can see there is a read error. So we can see we have received error over here because I directly entered the address 41441 into the Modbus read address, okay, to the QW3. It will not accept the same 41441 over here because it reads the data in a swapped byte, okay, or a different endian format. So I'll put the read Modbus address over here 41441. Okay, I'll give a trigger to send it. This is internal trigger. Now we can see that data has been flown to, okay, so that this data 41441 in a swapped byte is this. Okay, now this is the correct format. Now let us give the read request and if we check it, we can see the error. Okay, we can see there is no error and the read data is 0. So yes, the read data is actually 0. If we try to check into the SPRS, we can see OPS, this is the configuration, is 1P1. So OPS wiring configuration is 1P1, and if we look into the manual, 1P1 means we should read the value 0. Okay, now what I'll do is I'll change this configuration from 1P1 say to 3P1 and let's see whether it reads 8 inside it. Okay, so three P1. Okay, now I have changed it to 3P1 in the manual in the configuration, and if we try to read it now, again I am giving the read command. And we can see it has read a data 2048. Okay, so this 2048 is not swapped. When we swap this data, we will get C8. Okay, vice versa, we can also write the configuration. Now let us write to the same Modbus register. Okay, I am putting the same value, say 41441 wiring method. I am sending it. Okay, and I will send the data to Modbus write address after swapping. So let me swap it, giving the trigger to swap. Okay, so the swap data now has gone to the write address, and what we want to write, that you can provide it in write data, not directly, you have to swap it first. So the write data here we can provide, say I want to provide this 3P1, it has value 9. So I want to change that configuration to 9. So I'll put 9 here, change that data. Again I'll trigger. So 9 has been sent. Okay, and this corresponds 92304. Now let us give the write request, and the write request is successful because we didn't receive any write error. Okay, and the configuration has been changed. Okay, so the configuration has been sent with the write request. So if we check inside the device, we can see it has been changed to 3P1P1. Okay, so it has been changed to 3P1P1, which is the 9. Okay, if you try to read it again now here, say already in the read address we have the same address 41441. If we try to read, we'll receive here 2304 again. Okay, so 2304 received. So in this way, any Modbus mapping table addresses we can read and write into SPRS. Okay, thank you.